question pertains to a change in the National Electrical Code, specifically regarding the table number associated with motor full load amps. In the 2002 edition of the NEC, this table was referenced as Table 430.150. However, in the 2005 edition, the corresponding table number is Table 430.250. The inquiry suggests a possible correction of a typo as the reason for this change, particularly noting that Article 430 concludes at 430.245, which would make Table 430.250 a more logical successor. Without specific documentation or records explicitly stating a typo correction, it is challenging to definitively confirm this as the sole reason. Code revisions and renumbering of tables occur for various reasons, including organizational improvements, expansion of content, or alignment with updated industry standards. The NEC undergoes regular revisions, typically every 3 years, to incorporate advancements in technology, address emerging safety concerns, and refine existing requirements. These revisions often involve renumbering articles, sections, and tables to maintain a logical and consistent structure. Understanding the reasons behind such changes requires consulting the specific change documentation or commentary accompanying the relevant NEC editions. To understand why the table number changed, we must look at the history of NEC revisions and the specific changes made between the 2002 and 2005 editions. The NEC development process involves input from various stakeholders, including electrical engineers, contractors, inspectors, manufacturers, and safety experts. These stakeholders participate in code-making panels that review proposed changes and develop revisions to the code. The process ensures that the NEC reflects the latest industry practices and addresses potential safety hazards. The change from Table 430.150 to Table 430.250 likely resulted from a proposal submitted to the code-making panel responsible for Article 430, which covers motors, motor circuits, and controllers. The proposal would have outlined the rationale for the change, which could have included correcting an error, improving the organization of the article, or adding new content. To determine the exact reason for the change, it would be necessary to review the proposal and the panel's decision. Several factors contribute to the renumbering of tables within the NEC. Firstly, the addition of new tables necessitates the renumbering of subsequent tables to maintain a sequential order. Secondly, the consolidation or deletion of tables can lead to gaps in the numbering sequence, which may prompt a reorganization of the table structure. Thirdly, the expansion of existing tables with new information can warrant a renumbering to accommodate the additional content. The NEC is structured to provide a comprehensive set of requirements for electrical installations. The code is divided into chapters, articles, and sections, each addressing specific aspects of electrical systems. Article 430, which covers motors, is a significant portion of the NEC due to the widespread use of motors in various applications. The full load amp values provided in Table 430.250 are essential for properly sizing motor branch circuit conductors, overcurrent protection devices, and motor controllers. These values represent the current a motor draws when operating at its rated horsepower and voltage. Using the correct full load amp values is critical for ensuring the safety and reliability of motor circuits. If the conductors are undersized, they can overheat and potentially cause a fire. If the overcurrent protection devices are too small, they may trip unnecessarily, interrupting the motor's operation. If the motor controller is not properly sized, it may fail prematurely. Table 430.250 provides full load amp values for single-phase, three-phase, and direct current motors. The values are based on the motor's horsepower and voltage rating. The table includes values for various motor types, such as general-purpose motors, definite-purpose motors, and special-purpose motors. When using Table 430.250, it is important to select the correct full load amp value for the specific motor being used. Factors to consider include the motor's horsepower, voltage type, and service factor. The service factor is a multiplier that indicates the motor's ability to handle occasional overloads. If the motor has a service factor greater than 1.0, the full load amp value may need to be adjusted accordingly. In addition to Table 430.250, the NEC contains other tables and articles relevant to motor installations. For example, Table 430.52 provides the maximum rating or setting for motor branch circuit, short circuit, and ground fault protected devices. Article 430 covers various aspects of motor installations, including motor circuit conductors, motor overcurrent protection, motor control circuits, and motor enclosures. When designing and installing motor circuits, it is essential to comply with all applicable requirements of the NEC. This includes selecting the correct conductor size, overcurrent protection device rating, and motor controller. It also includes ensuring that the motor is properly grounded and that the installation meets all applicable safety requirements. The NEC is a dynamic document that is constantly evolving to reflect changes in technology and industry practices. Staying up to date on the latest NEC requirements is essential for electrical professionals. This can be achieved through continuing education courses, industry publications, and participation in code-making activities. Understanding the reasons behind code changes, such as the renumbering of tables, is crucial for ensuring compliance and promoting electrical safety. While the specific reason for the change from Table 430.150 to Table 430.250 in the NEC may not be explicitly documented as a typo correction, the renumbering likely resulted from a combination of factors, including organizational improvements, expansion of content, and alignment with updated industry standards. Consulting the specific change documentation and commentary accompanying the relevant NEC editions is recommended for a more comprehensive understanding of the change. In summary, remember that Table 430.250 in the National Electrical Code provides essential full load amp values for motors. These values are crucial for properly sizing motor branch circuit conductors, overcurrent protection devices, and motor controllers. Always refer to the latest edition of the NEC and consult with qualified electrical professionals when designing and installing motor circuits. The NEC is not just a set of rules, it is a comprehensive guide to safe and reliable electrical installations. By understanding the code and following its requirements, you can help prevent electrical hazards and ensure the safety of people and property. The full load amp values in Table 430.250 are determined through testing and engineering analysis. Motor manufacturers conduct tests to determine the actual current draw of their motors under various operating conditions. This data is then used to develop the full load amp values that are listed in the table. The NEC also considers industry standards and best practices when establishing these values. The full load amp values in Table 430.250 are generally conservative, meaning that they are higher than the actual current draw of most motors. This provides a safety margin to account for variations in motor performance and operating conditions. However, it is important to note that the actual current draw of a motor can vary depending on factors such as load, voltage, and ambient temperature. When selecting conductors and overcurrent protection devices, it is important to consider these factors and make adjustments as necessary. In some cases, it may be necessary to use a larger conductor size or a higher rated overcurrent protection device than what is indicated by Table 430.250. This is particularly true for motors that operate under heavy loads or in high ambient temperatures. It is also important to consider the voltage drop in the motor circuit. Voltage drop occurs when the voltage at the motor terminals is lower than the voltage at the source. Excessive voltage drop can reduce motor performance and potentially damage the motor. To minimize voltage drop, it is important to use conductors that are large enough to carry the motor current without excessive voltage drop. The NEC provides guidelines for calculating voltage drop and selecting conductor sizes accordingly. In addition to Table 430.250, the NEC contains other tables and articles that are relevant to motor installations. For example, Table 430.52 provides the maximum rating or setting for motor branch circuit, short circuit, and ground fault protective devices. Article 430 covers various aspects of motor installations, including motor circuit conductors, motor overcurrent protection, motor control circuits, and motor enclosures. When designing and installing motor circuits, it is essential to comply with all applicable requirements of the NEC. This includes selecting the correct conductor size, overcurrent protection device rating, and motor controller. It also includes ensuring that the motor is properly grounded and that the installation meets all applicable safety requirements. The NEC is a dynamic document that is constantly evolving to reflect changes in technology and industry practices. Staying up to date on the latest NEC requirements is essential for electrical professionals. This can be achieved through continuing education courses, industry publications, and participation in code-making activities. Understanding the reasons behind code changes, such as the renumbering of tables, is crucial for ensuring compliance and promoting electrical safety. The change from Table 430.150 to Table 430.250 may have also been influenced by the adoption of new motor technologies or standards. For example, the introduction of energy-efficient motors with different operating characteristics could have necessitated a revision of the full load amp values in the table. Similarly, changes in industry standards for motor testing and performance could have led to adjustments in the NEC requirements. The NEC is designed to be a flexible and adaptable code that can accommodate new technologies and changing industry practices. The code-making process involves ongoing research and evaluation to ensure that the NEC remains relevant and effective. When new technologies or standards emerge, the code-making panels carefully consider the potential impact on electrical safety and make adjustments to the NEC as necessary. The NEC also includes provisions for alternative methods and materials. These provisions allow for the use of innovative technologies or materials that are not specifically addressed in the code, provided that they meet the same level of safety and performance. This flexibility allows for the adoption of new technologies while maintaining a high level of safety. In addition to the technical requirements, the NEC also emphasizes the importance of proper installation and maintenance. Even the best electrical system can be compromised by poor installation or inadequate maintenance. The NEC requires that all electrical work be performed by qualified individuals and that installations be inspected to ensure compliance with the code. Regular maintenance is also essential for ensuring the continued safety and reliability of electrical systems. This includes inspecting and testing equipment, tightening connections, and replacing worn or damaged components. By following the NEC requirements and implementing proper installation and maintenance practices, you can help prevent electrical hazards and ensure the safety of people and property.